first.
Ah.
All right, here we go.
Doing weather shifts in New England. It's really interesting.
Oh, hello, everyone, and welcome to tonight's lifelong learning lecture. We are very pleased to have with us tonight Ken Mahan,
training from the
lead
library.
meteorologist. And just for a moment, I'm going to mute somebody.
Or
maybe. All right. Well,
Hello.
all right, sorry about that interruption. Welcome again. We are very pleased to have with us Ken Mahan, lead meteorologist for the Boston Globe, for his talk tonight on extreme weather shifts in New England, understanding and how to weather the storm. I am Tara Hall. I'm a media and production specialist here at the Framingham Public Library, and I'm also here to mute you if you have not already muted yourself. So I'm going to ask that if you haven't done that yet, if you will please do that to avoid any unintended interruptions during tonight's talk. I am going to be dropping a link into our chat to our evaluation forums, and we welcome any feedback you have about tonight's lecture and any topics you want to suggest for future lectures. And when it comes to Q&A tonight, there's going to be two of them. Ken will take a break during the middle of his talk to welcome any questions that you have. We're going to ask that you please drop them in the chat and I will read them to him. And if there's any questions remaining or that come along in the second half of his talk, please drop those in the chat as well, and we will follow up on those at the end of his talk. And with that, it's my great pleasure to welcome Ken.
Thank you so much. And I really appreciate everyone taking what would probably be the better half of an hour to talk with me about the weather. And I apologize in advance. I'm quite the science nerd. And if I get too deep within the statistics of things, I promise I won't dwell too much on it. But I really do appreciate everyone taking the time, especially because the Patriots are playing tonight. And so what better kind of pregame before 8:15's kickoff. So I appreciate you all taking the time to learn a little bit about the weather that's sort of been evolving over the globe through the United States, particularly in our neck of the woods in New England, because things are changing quickly. And for myself, I have the privilege of being able to sort of share all of the information that I've been able to gather over the last 7 years as a meteorologist. And like just mentioned, I am the lead meteorologist for the Boston Globe. I have a master's in meteorology. I did my undergraduate in meteorology, and like any broadcast meteorologist, I spent time really bouncing around the country. I spent time in Miami. I spent time in Anchorage, Alaska, my first station there, floated over to Wisconsin, and then found my way back home. Being a Worcester native, I worked for Western Mass News for a little while in the Springfield area, and then some time in Providence as well before joining the Globe. Over in March. I did have a stint in there where I spent a couple of years as a weather producer and meteorologist for NBC News. I was actually Al Roker's meteorologist for a while and had fun doing the super PowerPoints, as I like to call it, with all the weather maps that he would share on air during the Today Show. So learned a lot from so many people, great people in the industry, and I am very excited to be able to share sort of my backyard, as all of y'all's backyards, really, with weather and climate that's changing in the Northeast and New England. So really appreciate your time joining today. Weather is definitely changing. It constantly changes, during the day. Think of today, like the forecast was it was going to be rainy, but then last night this low pressure system didn't come into New England, and all of a sudden everyone woke up and it was dry. And it's completely complicated. The atmosphere is like a seven-layer cake with the Earth's surface sort of being the plate, and things sort of like a gears of a watch sort of change in the upper atmosphere, work their way down to the surface, and we experience weather constantly, right? So our daily decisions are based around it, and it's something that is so important, and particularly in New England, you're talking change, and with change becomes more extreme. And extreme weather really has sort of reared its head in multiple different forms over the last decade or two, from extreme heat to flooding rains, tornadoes, tropical systems, hard freezes, everything in between. It's New England sort of becoming a battleground towards significant weather that is becoming more dangerous, impactful, and really just needs to be a big problem that is addressed in practical ways for what we each can do, being informed, being prepared, and then really what we're seeing for future generations ahead, and what that means. So tonight we're going to dive in. We'll bring back sort of the eighth grade definition of extreme weather and really kind of evolve from there. Talk about, how climate change has really been contributing to the change in extreme weather across the Northeast and New England. And we'll really start to peel it back even further, talking about temperatures, precipitation trends, severe storm trends, i.e., tornadic activity, hurricanes, tropical systems, flooding, and sea level rise, which is a major concern, especially across New England, right? Boston and the Cape and coastal Maine and New Hampshire, all big deals. And we'll sort of, I mean, I had to take some time to trim down the examples because unfortunately we have a long laundry list of examples of extreme weather events in just recent years. So we'll go through just a couple case studies there and then really just kind of talk about a few certain things that you could do practically to stay prepared, to protect yourself, your loved ones, your family, your friends, your property, your assets, businesses, etc. That's really what it all comes down to at the end. How does weather impact us, and what can we do about it? And can we curb this growing problem that is really evident? And yeah, this is really clear. This graphic is really interesting to me because this is just the Northeast. This is the since 1980. How many billion-dollar disaster events impacted the Northeast? And it does expand a little bit out of New England. So this does include the state of New York and Pennsylvania and into New Jersey. But it's quite significant. You could see as we trend closer towards recent years, 2024, that graph starts to get pretty stacked up with the number of events. You're talking double digits in recent years, something that we hadn't really seen until 2010. But extreme weather, really the textbook definition is it's when weather events happen that are rare or unseasonal outside of the norm, right? We have the four seasons in New England, summer, spring, winter, fall, and of course we, experienced ebbs and, highs and lows, ebbs and flows within these four seasons. But, extreme weather is, what are the outliers? Oh my gosh, we were expecting temperatures of 80 degrees in August. Well, why are we getting 25, 90-degree days? Why are we seeing rainfall that is 5, 10, 15 inches above the climatological norms over recent years? And those incidents, those are extreme weathers. And that is something that has increased more in the Northeast at a much more rapid pace than across the country, right? We think of the Southwest with extreme heat, the Pacific Northwest with atmospheric river events bringing, plenty of rainfall. Down in the Southeast, the Gulf of Mexico, impactful tropical storms and hurricanes. But the Northeast is starting to see a confluence of all of these things, and I'll dive into the details of it. But, as a quick teaser, I guess, the jet stream, which controls literally the track of all the storms, has actually sort of parked over New England semi-permanently, and we'll talk about that a little bit later. But it has really boosted the amount of extreme weather events in the Northeast. And speaking of that, the average annual number of billion-dollar disasters in the Northeast is three. It seems like a low number, but of course, billions of dollars we're talking. So that's significant impacts to infrastructure, property, casualties, of course, all certain insurance claims that comes with the result of severe weather that affects people and businesses. And in the past 5 years, this average has over doubled, 7.2 events in the last 5 years, which is extremely off the scales. It's something that isn't happening across as a high rate across of the other parts of the country, and it's costing a lot of people a lot of money, a lot of time, and a lot of frustrations. 2024 as a country just got through the $10th billion disaster with the last tropical system that pushed through, and that we're in September, right? We still have at least a quarter of the year to go. It's going to be really interesting to see what that number ends up being as we head into the depths of the hurricane season, as we get into sort of the second wave of severe weather season, not so much in New England, but as it impacts the United States. And then we head into the winter time, right? Icing events, heavy rainfall events. November actually ends up being the most rainy month of the year, more so than springtime in New England. So, not a good sign for what's to come. But as I go backwards, but yeah, we'll dive into that because obviously the dollar signs are apparent there with how much money goes into the restoration and recovery of severe and extreme weather. The big picture, it's macro level, it's climate change. It really is at the end of the day. It's trends, and we'll go into each specific trends that we see in a few minutes, but climate change really is the main driver behind what we are experiencing in New England, across the country, across the globe. And it's changing at a remarkable rate. Climate change alters that baseline of, the conditions needed for localized weather events. And when you have different conditions, more extreme temperatures, more extreme precipitable water in the atmosphere, then it sort of changes the rules of the game. And that doesn't make it fun for really anyone. And what was once rare or uncommon is being much more common as we see the frequency of severe outlier events become the norm. And that's not really fun. And we see that with warmer air in the atmosphere. We see that with sea surface temperatures really booming, and that's altering weather patterns as well. And that's at the synoptic scale and at the macro scale as well. Like I mentioned, the atmosphere is a 7-layer cake with so many different components happening through all the spheres that makes up the atmosphere, and all of those layers are changing and evolving, and unfortunately not for the better. We can see it really kind of portrayed here. Greenhouse gases in the atmosphere have nearly doubled since 1980. That's a short amount of time for a lot more greenhouse gases in the atmosphere. And you're talking carbon dioxide, methane, water vapor. That absorbs all those elements, absorb heat from escaping from the atmosphere, particularly at night. And it's like when you're warm and then you decide instead of putting on the air conditioner, you're gonna put on like a quilt or a comforter, and it's just gonna keep that heat compacted towards the surface. And that doesn't really help anything because that actually has shown since 1990 that the available energy in the atmosphere, what meteorologists call the heat influence, has increased by 50%, which that's a lot of power. One tropical system has enough electricity within it to power the globe 7 times over. And when you increase that by 50%, I mean, you're talking beyond nuclear level, beyond sort of understanding of how much energy is actually around, and that makes things harder to predict as a meteorologist, and unfortunately makes it more sort of unbearable to see the impacts of what storms can do to coastal communities, to mountainous communities, low-lying communities, especially, and really just the evolving landscape of the country. So, there we go. I keep going backwards. Yeah, so how does it impact the weather, right? Baseline being the warmer atmosphere, with more carbon emissions, more fossil fuels being burned into the atmosphere, and seeing all these greenhouse gases rise. The atmosphere, bar none, is much warmer than it was in years past, right? So the warmer the air, the more moisture it could hold. And so for every degree the atmosphere becomes warmer, you actually get 4% more water vapor in the atmosphere. And that actually is pretty astounding. It's like when you start filling up a sponge from your sink and, yes, over the first, little bit of time, you're not really seeing the water go through, but then eventually, that sponge becomes full and water just has no more room in it and it overflows. And then when you wring out that sponge, poof, water comes flowing out like at an unprecedented rate. And that's sort of what happens with the atmosphere in these storms with some times. And that leads to more intense rainfall and increases the risk for flooding, especially over landscapes that aren't really used to seeing such heavy rainfalls, more rainfall events to that degree. And climate change is a big driver behind that. Like I mentioned, warmer the atmosphere, warmer the air temperatures, the more energy simply is available to produce storms. Increased temperatures mean more room for storms to grow. Usually when you talk about localized weather events, there's certain things that we talk about like a cap or temperature inversions or things that will prohibit air from rising, condensing in the atmosphere, and then, ending up being a thunderstorm. Well, if there's simply more warm air, more moist air in the atmosphere, well, storms can grow further, higher, wider, and ultimately grow to a point where they're just much more impactful as they get to the mature stage of the thunderstorm to bring whatever it is that they have down to the ground, meaning heavy rainfall, hail. Hail has been a big problem in the last couple of years, especially in New England. New England, believe it or not, I mean, this past, summer, we had quarter-size hail events, which doesn't really happen very often. Most times, especially, we see maybe grapple or pea-size hail at most. That doesn't really do a whole lot, but there was some significant damage in July and August from storms that produce hailstones over a quarter size, which is pretty impactful, especially if you have like a quarter or a golf ball falling from 30,000, 40,000 feet up in the atmosphere. Not a good thing for roofs, not a good thing for people walking about, and not a good thing for vehicles, of course. And that's a big problem. Warmer the air, the more sea levels rise. Warmer atmosphere expedites rising sea levels for a number of reasons. Well, the reasons are because, warmer air, it travels farther towards the poles. Then you start talking about a rapid reducing of glacier ice, and that will bring more water into the oceans, rising sea levels, raising concern for coastal flooding, especially with coastal storms, because with a warmer atmosphere comes hand in hand, you're talking a warmer sea surface temperature, and having warmer waters means you can evaporate more heat out of the water to fuel storms, and we see that with tropical systems all the time. And then lastly, the warmer the air, the more erratic weather can become. You start seeing warmer air in different levels of the atmosphere, higher latitudes, and that actually starts to change positions of traditional wind patterns, i.e. the jet stream. I mentioned it earlier. The jet stream does, of course, ebb and flow north, south, east, west, on a day-to-day, week-to-week sort of synoptic level. But now we're starting to see a little bit more permanent placement where the jet stream has, especially in New England, has for the last 2 years has really stayed stuck over, oftentimes as south as Rhode Island or Connecticut, as high up as of Maine, the U.S.-Canadian border, and that doesn't do well because, like I said, the jet stream is like a traffic cop. It tells exactly where storms to go. It influences storm patterns from your traditional cross-country mid-latitude cyclone to your tropical systems, and that doesn't bode well for us. And yeah, and unfortunately, it's a trend that isn't really slowing down anytime soon. But we'll talk a little bit more globally, especially with some of these examples when we talk about, surface air temperatures and then sea surface temperatures, and then we'll drill down to the United States level, and then we'll really take a look at the Northeast and New England. This map here is from the Climate Change Service. They do an incredible job, extremely accurate depiction of recording, the global surface air temperatures from over tens of thousands of official observation sites. And They have been tracking really global surface air temperatures since 1940, and it's been exceptionally above average, especially as of late. 14 of the last 15 months either tied or set the warmest months ever recorded. This is dating back 1940, so we're approaching, 90 years or so, and that is unprecedented. There's a chance where, the summer became a little bit cooler globally than 2023, which was record-breaking by a long shot. We're coming out of a very, very warm winter and a very warm spring, and I wouldn't be surprised with what I see for a setup, especially in New England, a more warming trend as we get into the depths of October, November, and then to close out the year. So there's still a chance that 2024 will end up outpacing 2023 for the warmest year globally. And but to break away a little segment, this was actually just released a couple days ago. This summer, 2024 was the hottest ever recorded, which isn't good, and this is globally. So, not ideal as it looks for when you're thinking climate change. The pace at which we are going when it comes to air temperatures around the world. Unfortunately, sea surface temperatures not really, showing any signs of hope for us, right? As far as that pace of heat, right? Consistently higher over the past 3 decades than any other time since the records began for this element with sea surface temperatures in 1880. 2023, the warmest year on record. 2024, again, same sort of situation with the air temperatures pacing slightly behind, coming out of an exceptionally warm winter and an exceptionally warm spring. It did cool down a little bit, and little sidebar, it's mainly because there is a developing La Nina that tends to cool down the surface temperatures around the equatorial waters just west of South America. And there's this other phenomenon called the Atlantic Nina, which actually sort of stifled our hurricane season a little bit, that had brought cooler temperatures to the equatorial Atlantic, and that has brought our readings down slightly, but we're still pacing pretty high, where we're going to be contending with 2023 as the warmest year on record with global sea surface temperatures. As I mentioned, the ocean absorbs a tremendous amount of heat. It increases those temperatures. The ocean's current will transport these warmer than average waters to various parts of the northern latitudes in the northern hemisphere, vice versa for the southern hemisphere. And with that, you start introducing different weather patterns that are impacting areas that haven't really experienced storms developing because of nearby adjacent warmer waters, right? Because warmer waters, they release more water vapor in the atmosphere, and it could fuel violent storms. Now, drilling down, taking a look at the United States, right? This graph really sort of spoke out to me because this dates back to 1895, right? That's a long time, long track of records. And you can see, the below average temperatures here in blue, the above average temperatures in red. And take a look at, essentially from 1996 onward, we have been above average exponentially with the average surface temperatures across the United States. That is an astounding sort of discovery here, right? You're seeing 2024 likely to become the warmest on record for the United States. Coming out again, once I said, a very warm winter, a very warm spring. Nearly a dozen major metropolitans recorded their highest daily temperature ever. You're talking places like Phoenix, you're talking places like Dallas, Houston, even pushing towards Atlanta, up towards Chicago. Boston came close. A few sort of regional cities recorded some exceptional temperatures this year. Not the highest ever recorded, but within the top three, top two, and that includes Hartford, Connecticut, Springfield, Mass, Burlington, Vermont, Manchester, New Hampshire, Concord, New Hampshire, and I think that's it. Portland, Maine escaped it, but they did have a few times where they were seeing top 10 temperatures, which is insane, really, at the end of the day. I don't want to get too far ahead of myself, but what was it? Concord, New Hampshire, Manchester, New Hampshire had 2 weeks straight of 90-degree temperatures in the month of July leading into August. Boston had a good chunk of 90-degree days as well. Heat waves becoming more common, and that's the problem with sort of what New England was once used to, and we unfortunately have to adjust to. But yeah, so this is really taking a look now at the Northeast in New England, right? This graph really depicts the Northeast average temperature from 1895 to current day. This blue line shows the average trend throughout the decades, right? And when you see the incline, obviously that means increasing temperatures. And it's really the rate of which the increase of annual temperatures across the region is the biggest concern. 0.2 degrees per decade versus 0.08 per decade against the global average. And I checked the stats. New England specifically is warming at a faster decade over decade rate than much of the country, much of the world. And it is in part due to the proximity to the rapidly warming oceans. You're talking the Gulf of Maine, you're talking the Northern Atlantic seeing astronomical numbers. Of course, the Gulf Stream rises right up the East Coast, and it's bringing sea surface temperatures of 85 to 90 degrees off the coast of Florida, off the coast of the Carolinas into our region during the summertime. And it's just adding more fuel to the fire to bring these temperatures pretty significantly higher above average over the last few years. And look at this, since 1996, all the way up to present day, we have been above average. And that is pretty scary, right? What does that mean? I know this last summer, there was I did a piece in the Globe about just how warm overnight temperatures were in the New England area. And mainly, with more temperatures, the more warmth in the atmosphere, it holds more water. And like I mentioned, more water really just keeps heat in place, because when the sun goes down, typically these warm surface will evaporate the warmth and it will escape freely into the atmosphere. But when you have all of these blockers, i.e. water vapor, that that heat can't stay. Or it can't get out of the atmosphere as freely, so it stays in place, and that ends up keeping our overnight temperatures much more warmer than we have, and that brings a lot of problems. There's many people that don't have available air conditioning, or live in very certain circumstances where having overnight temperatures that are running 4, 5, 6 degrees above average doesn't give you the relief when you're trying to relax or unwind or just catch your breath from a 95-degree day. So not a great sign there. And our geography placement with the Atlantic Ocean right offshore isn't really helping our cause. How do warmer temperatures impact heat waves across the region? I sort of mentioned with how the Atlantic Ocean has really helped fuel the atmosphere and bring more water vapor into the region to keep heat in place. But since 1961, New England has seen the highest jump in heat wave intensity, and our heat wave season has extended much farther than most of the country. A heat wave, just textbook definition, and it actually changes depending on where you are in the country. But for the Northeast and New England, a heat wave is defined as 3 consecutive days of 90 degrees or hotter temperatures. And we saw multiple instances this last year. We've seen multiple instances, a rising amount of 90-degree days in the last 20 years as well. You're talking 20, 25, 30 across New England, and that hasn't that hasn't really been slowing down without an outlier year here or there, but it's been pretty consistent. But yes, so heat wave intensity, that is really just how hot is it actually getting? Well, it's getting much warmer in New England when in terms of heat wave, over an inch and over a degree to a degree and a half in New England, specifically Boston. I pulled out the numbers for the sub-regions: Worcester, Springfield, from Burlington, Vermont, going into the major cities in New Hampshire and Maine. Same thing. You're seeing heat waves a degree degree and a half. Some regional areas away from the coast, when we do sometimes get relief with a marine breeze at time, but the inland areas are having their heat wave intensity rising to 2.5 degrees warmer than what heat waves used to be. I can see a scenario where 10, 15 years down the road, we actually might have to change the definition of a heat wave in New England if this heat wave intensity trend continues on. And another thing worth pointing out is just how long we are experiencing heat waves. You used to think just 5, 10 years ago, heat waves occurred, oh, that's a July thing, that's an August thing, and only stays contained in the summer. But we're actually seeing it now occur more times in May and more times in October. And we can see a lot of New England is actually seeing a trend of 25 to 50 more days in the summer season, or summer-esque season, I should call it, because we are experiencing more heat waves for longer periods of time, because summers are getting longer in a sense, and our springtime and our falls are actually shortening up a lot in recent years. Speaking of temperatures, especially during winter, um, winter has, especially across the Northeast and in New England, has been above average during 16 of the last 20 winters. You can see that trend of red going through current day. And this last winter was almost exceptional across the board with how warm it was. It was the warmest on record through and through, from Boston to Hartford to Worcester, Springfield, and parts north. And it was the first time that the average temperature with all of the states in the Northeast averaged above freezing, 32.1 degrees. And this dates back all the way to 1895. So you might think, well, we didn't really have that much snow this last winter, and you're absolutely right. We actually haven't had that much snow in the last several winters because the temperatures are just much more higher, and that takes that sort of chill out of the air. And obviously, you need cold air in order to create snow, and then we start talking more rain events in winter and how that impacts, and that extends flooding incidents, and that becomes more of a problem. So, I'll take a break here and see if there's any questions that anyone may have I can answer. And before I go into the second half of the presentation, and feel free to drop them in the chat if you haven't already.
Thanks, Ken. So we do have a question already in the chat. Mary asks, do you think that the seasons are shifting, meaning winter starts later and spring later, etc.?
Definitely. I was digging through numbers last week for a separate thing I was working on with the globe, and absolutely, it's you're talking warmer temperatures extending through the end of October into November, really shortening fall a lot. With winter time, we're seeing a trend where it's actually becoming much warmer in the end of February and the beginning of March, rather than what used to be, seeing snowstorms late in March, early April. And unfortunately, the heat component of it has prolonged summer. So if you're a summer lover, then that's great news. But unfortunately, our winters are shrinking. They're starting later and ending sooner. And our transitional seasons, spring and fall, are also sort of being not as transient as far as reducing temperatures to the seasons that we have all been accustomed to, 15, 20, 30 years ago.
Mm-hmm. I'm going to tack onto this question because I'm curious to know if the trend that you're seeing, are we headed towards having fewer seasons?
Oh boy, yes. I don't want to let a lot of people down. I think that we're trending towards seeing fewer vibrant seasons, right? I'll think about the example of what's happening right now, fall foliage, right? Everyone gets excited to go, take a drive up north, Western Mass, whatever the case may be, to check out the beautiful colors with the trees. And traditionally, you would expect temperatures to gradually cool and, for leaves to sort of take their time transitioning their colors, and that happening towards the end of September in the northern tier of New England, and then into the middle part of October in the southern, portion of New England, Massachusetts, Connecticut, and Rhode Island. Unfortunately, we are seeing less precipitation in the last 45 days or so. A very different weather pattern that we haven't really seen in years past that has actually stressed the trees to the point where foliage is already ramping up. And that unfortunately will take sort of that vibrancy out of the beloved fall season, and that could be a trend that will continue to happen where the colors might not be able to pop as much. The timetables may continue to change. Should we start seeing more extremes when it comes to our weather patterns for the fall? I spring is interesting because you used to be able to see that gradual increase in temperatures, but over the last 7 to 10 years, it really feels like you go from winter to, okay, it's summer, and spring lasts maybe a week or 2 weeks at best. I remember, the whole the saying of, April showers bring May flowers. Now it's like, all right, well, April is showers, May is showers and hot, and now it's June and it's full-fledged summer. So it's things aren't as sort of vibrant in the sense of being able to experience each season for what it is. You're starting to see a much more extended summer and then the reduced transient city seasons of fall and spring. And unfortunately, if we're staying par to the course here with these temperatures and the precipitation increases, then we're going to be dealing with this sort of scenario worsening in the years to come.
Mhm. Okay. Well, we've got one more question for you in the chat from
Oh, sure.
Sharon.
Cool.
One can't help thinking about snowpocalypse. She thinks it was maybe 2014. You might remember better than we do, but Sharon, I remember that winter as well.
Yes.
Was that climate change or is there a risk of another?
That's a great question. Climate change, like I said, it sort of changes the rules of the way that weather works. But at the lower levels of the atmosphere, the more sort of micro scale patterns, surface high pressures, surface low pressures, dynamic shifts in wind direction, that can, keep things, more of a sort of practical sort of a normal, we'll say, weather pattern. I remember snowpocalypse, and that was just a classic scenario where extremely cold air from Canada came in with a very, very, very moist air mass coming up the coast of New England. And climate change certainly played a role in the way where, you have this low pressure system that's sitting off this extremely warm ocean for the time of year. And that just, boy, that sent so much moisture into the mid levels of the atmosphere, the surface levels of the atmosphere, and that brought so much snow across the region that was an impactful system. That was an impactful system. So it's sort of hand in hand where, yes, the exceptionally warm ocean temperatures because of climate change really helped amplify those localized sort of in the now weather patterns where that dominant high pressure of cold Arctic air really kind of wrung out. It's like wringing out a soaked towel. And when those two systems collide, you just dump out so much moisture from the atmosphere. And, in that case, it was snow.
Mhm. All right. Well, we've got one more question before you go ahead.
Oh, sure.
So Reno asked, how are farmers handling these changes, which really are impacting their crops?
Wow. Yeah, it's so funny. I had this conversation 2 weeks ago. It forces their hand, right? It forces the hand to unfortunately spend money, leverage technology to really bite into their margins to prepare for any sort of weather mitigation that may come to crops. Agriculture is the largest industry that is most impacted by extreme weather. That's in the Northeast, that's across the country, that's globally, right? South America had a very, very poor growing season, and they export a tremendous amount of fruits and vegetables to the United States and across the world. And their harvests were only 30, 40, 50% of what their yields usually are. And that is absolutely due to climate change factors that have brought more of an arid environment across those farms and yeah, that unfortunately is something that agriculture industry folks have to really lean on weather guidance, climate guidance in order to position themselves to stay ahead of the game. There's a private consulting company that I've done work with before, and we focus on agriculture, and it's you see farmers that have 10 to 1,000 acre farms, and the weather is becoming much more extreme. It's impacting different areas on their farmland. And so what they are trying to implement to mitigate risks has to change on one crop or another, or in one location or another, because there's so much more diversity as far as weather extremes that are impacting farmers. And unfortunately, us, we go to the grocery store, and an element that we see with increased prices, because like I said, farmers, their hands are forced when it comes to making the necessary adjustments to stay ahead of a changing environment that they're just not used to.
Mhm. All right. Well, I invite anyone who has a question to drop it in the chat, but in the meantime, Ken, why don't we keep it going?
That sounds good. Yes, feel free to drop it into the chat. We'll do another Q&A at the end, especially as I dive in a little bit more locally, talk about precipitation, flooding, a couple severe weather events. Feel free to share any events that you might have experienced yourself. I could talk about, tornadoes. I actually chased this tornado behind me back in 2018. That was the closest I ever got to a tornado. I'm a meteorologist, and I was scared. So, but any questions or any memorable storms that you all can remember, feel free to drop that in too. Happy to chat with you. But yes, let's continue on. Precipitation. How is precipitation trending across the Northeast? You all probably know the answer by now, but that warmer atmosphere, it's parallel, the increase in temperatures with increase in precipitation. Again, warm air holds loads more water vapor, 4% more water vapor across a gigantic atmosphere per degree warmer. That turns into this, what we're seeing, increased precipitation across the region. The average precipitation in the Northeast has increased by 0.5 inch per decade, and over 1.15 inches per decade since 1960. That is by far the sharpest increase across the country since 1960. And we're seeing this. We're going to get into a couple case studies here in a few, but it seems like flooding is becoming a much more common event across New England. This past summer, certainly in 2023, was like almost the wettest year across the board for New England, and this trend is increasing, and it doesn't really bode well, as we are increasing the fastest rainfall rates, like I said, in the United States, but also in the world. We're not the fastest in the world, but we're up there. Only 2001 and 2016 saw below average rainfall in the past 25 years. You can see the trend. That's the average. As it grows, as we get closer to current day, you can see some spikes here with some really active years. It's physics, folks. It's the more temperatures, the more precipitable water, and that doesn't bode well, because it's basically, you just need to, it's like the fuel to a fire. You just need the flame, which is a surface system, a low pressure system interacting with a cold front, a tropical storm developing over warm water. All of this will really purge out the water from the atmosphere, and we see it as a result in some really impactful weather across the region. Precipitation from heavy storms has increased 70% in New England since 1958. That's a big deal. You're talking, and I'll go left to right here, but you're talking, the distribution of flood risk versus the average has grown exponentially across the New England area over the last, couple of decades. And that really has been a major concern. Folks may feel it with changes in their insurance policies, or increases, or unexplanatory increases in your insurance policy premiums. A lot of it has to do with the increased flood risk, especially with property and commercial property insurance plans across the region. Not great. You're seeing much more of a dramatic increase across the East Coast over the last few decades as well. insurance companies have pulled, a lot of insurance companies have pulled out of Florida, have pulled out of Texas now, have pulled out of California and parts of Oregon and Washington just because they are well aware of what's happening, and they're not committing to insuring folks because of the repeat offenses of 1 in 100 year floods, 1 in 1,000 year floods. And that distribution, this is according to FEMA, in 1 in 100 year floods across the Northeast and New England is now down to 1 in 20 years, 1 in 30 years, a rapidly decreasing time span or distribution of return for significant flooding that you would only see 1 in 100 years. Well, now you're seeing it happen 1 every 2 decades, 1 every 3 decades. And that rate, unfortunately, is amplifying, where I wouldn't be surprised by 2040, we actually see what was once 1 in 100 year floods from the late 60s, now 1 in every 5 years, which is not a good thing for the Northeast. Speaking of severe weather and hurricanes, we'll dive into some of the science behind it, then we'll get into some of the weeds. Of course, like I said, I'll beat this drum all day because it's the stem of really how everything works in the weather that we experience. Warm atmosphere holds more moisture. Warm oceans can evaporate much more moisture into the atmosphere. And the more humid the air, the more unstable the atmosphere can become. You're talking at a very micro scale, i.e. the tornado in the picture. This is 2011 Springfield tornado that did a tremendous amount of damage in Western Mass. Or you're talking to the scale of a gigantic tropical cyclone, or even a massive mid-latitude cyclone, which is sort of the same scenario. You have a swirling low pressure system that's traversing across the country. Those are becoming much more wider, much more frequent, much more impactful as far as as they impact folks across the country. Humidity rises, sometimes aggressively. It produces the most severe storms that results in damaging wind gusts. There's this term called derecho, which is really just storms that regenerate over a period of time as they traverse over a few hundred miles, and it's just constantly fueling, taking this moisture, sending it into the 10, 20, 30,000 foot mark in the atmosphere, condensing, and then just a sudden downburst will gust winds for 70 miles per hour over an extended period of time. New England, fortunately, hasn't had a derecho in a very long time, but it's more of a common occurrence that's happening across the country. Hail, we talked about hail, more hail events that's happening in New England. More larger hailstones up to golf ball size hail have been falling from the skies over the last severe sort of portions of the summer, and then more tornadoes. All of this moisture, this available energy, it's really what's needed in the atmosphere for thunderstorm development. This is sort of my favorite term when it comes to severe weather. It's called CAPE. I'm sure some of you have probably heard about CAPE. It's the convective available potential energy in the atmosphere. It's a calculation to determine how much energy is available to fuel a thunderstorm. And the higher the CAPE, the more unstable the atmosphere becomes. More moist air. Hot air is lighter than cold air. Moist hot air is much more lighter than cold air. And what happens during severe storms, that warm, moist air will build until it becomes much lighter than the environment around it, i.e. cooler air, and will rocket into the upper atmosphere. That's why when you see storms develop on social media, on local news or what have you, you see these towering cumulus clouds that form, and some could get into really interesting supercells that are just massive. Well, that's just because you have so much available energy because of the moisture that's available at the surface that gets sent into the into the higher parts of the atmosphere. Well, I say all that to say this: the average amount of days with CAPE, that is 1,000 joules per kilogram, is much more frequent in New England. In fact, 20 to 40 more days are more filled with CAPE of 1,000 or more since 1979 in our region. That just means frequency of severe thunderstorms, duration of severe thunderstorms, and the intensity, unfortunately, of severe thunderstorms across the region is building. That's more than a month. That's more than a month of severe thunderstorms that we have to be concerned about or be weather aware about as we go about our day to day. As far as, timing for that, you start to see sort of with that summer expansion, more severe activity happening in May and more severe activity occurring in October. However, May, you have much more available moisture than in October, so you see it more front loaded as far as when are we seeing these more severe thunderstorms occur. Thinking about hurricanes, tropical storms, a semi-permanent strong high pressure system. It's called the Bermuda High or the Bermuda Azores High because it floats between the Bermuda Island and then over into the eastern Atlantic, closer towards the Azore Islands, part of Portugal. This is a semi-permanent feature, and it helps direct coastal lows or tropical systems north through the northern Caribbean or the tropical Atlantic, we'll call it, and it'll come up this way and start materializing and track and get caught up in the jet stream that is much more commonly set up over New England. And this is a natural pattern that is now amplified due to increasing climate change. Reason being, when you have a warmer atmosphere, when you have warmer sea surface temperatures, it creates much larger pressure gradients between high pressures and low pressures. High pressure is cooler air, more dominant sinking air versus low pressure, which is hot, moist, rising air. And it's basically high pressure always wins against low pressure. So this high pressure system has been becoming more stronger at times, sending more storms frequently towards the coastal United States rather than having storms sort of drift off and stay a fish storm, as I would call, when it comes to tropical storm season. But coastal lows, essentially, if anything, especially in the winter months, we think of nor'easters. Coastal lows usually form off the edge of South Carolina, North Carolina, and then they don't want to go east because this high pressure system pushes them right up the coast, and that's why we get our nor'easters with more amplified sea surface temperatures, atmospheric temperatures, and then that difference in pressure between the high pressure system in the Atlantic and then whatever coastal low is forming. We see a much more dramatic intensification um, within these systems. You may have heard many meteorologists over the summer or any tropical or hurricane seasons use the term rapid intensification. That is because these changes in barometric pressure are happening much more quickly, and these storms develop faster, more intense at a faster rate, which gives folks more to worry about because great intensity is much more higher than anticipated. But oh wait, this is actually intensifying and coming to impact me much sooner than years past. So it's something to keep in mind as the years move forward. Increased sea surface temperatures provide an uninterrupted fuel supply to coastal and tropical systems, and they build the storms stronger and larger. Sea surface temperatures and this has been consistent. I thought about pulling out all these years of sea surface temperatures anomaly, or in other words, just how far away from average are these sea surface temperatures? Are they a degree above? Are they a degree below? Over the last 15 to 20 years, most of these have been exceptionally high and exceptionally above average. And you can see 1, 2, 3 degrees warmer than average are the sea surface temperatures for the entire North Atlantic Ocean, the Caribbean, the Gulf of Mexico. Thinking I just did a piece today on another tropical system that is looking like it's going to head into Gulf of Mexico. Why? Because they have exceptionally warm waters. Sea surface temperatures 87 to 90 degrees, unheard of, and they actually might get yet another tropical system landfalling at this time next week. But as far as New England is concerned, that Gulf Stream has been funneling a lot of warm water up into our region, which is amplifying storms. This is not just this year, this is years past over the last decade and a half. And then I'll get to this in a second on the right side, but look at the Gulf of Maine. It is the warmest or I'll put it this way, it's warming faster than any body of water that is, or body of salt water across the globe. And that does not do us any favors when it comes to low pressure systems that are that are moving up the coast, they can intensify once they start hitting the Gulf of Maine, brings much more impacts, heavy rainfall into Maine, into southeastern New Hampshire, eastern Massachusetts, from Worcester, Framingham, into Boston, Cape Cod. Um, it's tremendous how warm the Gulf of Maine has been warming. The global average is here in the green. The blue is the average for the Gulf of Maine, 0.87 degrees Fahrenheit per decade. That's over double the rate as far as the global ocean warm rate. Um, that is mainly due because the continental shelf is much more sort of shallow versus other areas in the world. So when you get more warm air in the atmosphere, more intense heat that sort of blankets the ocean, it pushes the heat content, as we call it, further deep into the ocean, especially when you have not as much water per depth versus other areas of the world. And that unfortunately has made the Gulf of Maine much more of a hotbed when it comes to sea surface temperatures. Sea levels aren't really doing us any favors as well. Looking at globally, the average sea level has risen 8 to 9 inches since 1880. That is quite extensive. In 2023, the average sea level was almost 4 inches above 1993 levels. So it's increasing at a faster rate. This is the highest annual average since records began in 1993, and the rate of rising is accelerating, doubling from 2015 to present day. That's a big problem. We talked about, how does surface how does air temperatures impact sea levels, right? You see fasting meltwater, you see glaciers really deteriorating at a faster rate, and that doesn't help things whatsoever, because when you get more water, cooler water from melting glaciers sinks down to the depths of the ocean. It doesn't evaporate as quickly, and then we see these rising sea levels as a consequence, which could definitely pose a problem to New England specifically. Also, because the Gulf of Maine, again, it's shallow versus others. So, when you get more water, water isn't going to have really much of room to go deeper. So it's going to be pushing into the coast from Cape Cod into the main coastline over the next 50 years and onward. But yes, over the next 50 years, you're talking that sea levels may rise as high as 2 feet in some spots. That is a major concern. 8 inches in Boston since 1950. That we see that constantly. You may see local news, or you may see things called the king tide, which actually is happening tomorrow. There's a king tide tomorrow with the full moon, and there's a coastal flood watch that's out in Boston, and that is going to bring water up over and start spilling into the seaport area, the waterfront area. You start seeing those coastal roadways from Boston to Quincy start splashing over into Winthrop. It's a big deal, and 8 inches is a lot of water in just a short amount of time from 1950, and it's going to increase even at a more rapid pace. Coastal New England has increased a foot since 1900, which is higher than the global average. And the low slope, like I said, off the northeast coast, will make it especially vulnerable to coastal flooding and erosion. Check your local news tomorrow. The king tide will be around 1:30 in the afternoon. I think I forecasted the tide to reach over 12 feet in some and to rise to 12 feet in some spots, and that's going to bring up to like a foot of water in some spots in Boston, down into the Cape and everything, and it's not fun. But yes, you could see, it's hard to really get into the nitty-gritty with each and every location here, but you're talking inundation, rising sea levels, pushing hundreds of feet into up to a quarter mile or so for the extreme low level areas in the next 50 years, which, I mean, how many folks have properties right on the water, businesses right on the water, especially in Boston, that are going to be impacted. And unfortunately, the rate of change in the climate is moving at a much faster pace than human intervention. That said, this was probably the hardest part of the lecture, trying to like narrow down, like, okay, what do I want to dive in for case studies? there were a ton, and I could go on forever about it, but just a few certain examples here as my computer froze. 1 second. There we go. We are back. Of what has happened with extreme weather in the last sort of 10 years or so. Um, Vermont got devastated last year. 2023, that summer was ridiculous. Multiple instances of heavy flooding coming from coastal lows, from remnants of tropical systems, which, by the way, New England has seen. I know New England hasn't had a hurricane or an active hurricane since Hurricane Bob in 1991. But New England has seen so many tropical, system remnants come through the region over the last 5 years than any part of the country. Again, the weather pattern has sort of shifted naturally where um, these systems, they may come in from the southeast, the coast of Carolina, they may come in from the Gulf of Mexico, they get caught up, and then the jet stream influences them to come towards the northeast. And Vermont got hit twice with last year with similar situations. Large coastal low moved over central New England and then it stalled. Copious amounts of moisture in the air. Dew points over 70 degrees. That is oppressive. An uncommon thing that this past summer has been very common. Dew points were the highest ever in parts in the New England area this past summer. Multiple days with readings into the 70s. But that's another probably another case study in its own self. But copious amounts of moisture dumped 3 to 10 inches of rain within 48 hours, breaking numerous daily records. But the problem lies where Vermont's steep terrain is not used to it. It doesn't even have the chance. The geology of the terrain up in Vermont is it's rock. It's hard sand. It can't absorb rainwater of that amount. Um, Nearly to the pace I need to in order to avoid what you see in Montpelier in the image in July, that extensive flooding as high as the bridge that was crossing the river, and then property, commercial property, residential property, just inundated with feet of water. Exceptional runoff is a big problem, especially in mountainous New England, the Berkshires, Vermont, central and northern New Hampshire, going into parts of western Maine. Um, you get a lot of rain that falls. If you're on the slope terrain, you're going to see water just hit the ground and just rocket off and go towards the lowest point that it could possibly find. These rivers, these streams, they swell so fast, they spill over into roadways, extensive property and infrastructure damage to homes, businesses, roadways, railways were a result of this system that came through Vermont last year. And unfortunately, they had a similar system follow up that just weeks later, which didn't really do anything. I like to point out Hurricane Ida, the remnants there in August of 2021. This was a long track storm, made landfall in Louisiana. Poor Louisiana, they've been getting landfalling hurricanes year after year. They are struggling with that. It just seems like they have a magnet for storms. They had, a couple tropical systems already just this year impact that region. But for us, Hurricane Ida, a ferocious hurricane that turned post-tropical as it came into the United States. But the thing was, in August, there was so much moisture in the air in the mid-Atlantic, in the Northeast, and then into New England, where yes, it didn't have its tropical characteristics because it wasn't receiving a fuel source from the sea, but it basically had the cousin of what would be like an active, system over water over New England, delivering 4 to 8 inches of rain within a day and a half window. Local amounts reaching 10 inches across southern New England. This was so much rain that the Northeast spent 16 to 24 billion dollars recovering from the amount of flooding that happened from New York into New England and into Maine and then Nova Scotia. Even though Nova Scotia had a problem with it, those numbers don't apply to the 16 to 24 billion dollars. But you're dealing with gusty winds, power outages. You're dealing with numerous tornadoes that were wreaking havoc. A couple towns in Cape Cod got decimated by a couple tornadoes due to that circulation pattern from the remnants of Hurricane Ida. Did not bode well. Much more intense. It was in a very extremely warm summer very warm sea surface temperatures with that storm as it came off of the coast of New England helped just give it a little bit more juice to make things much more impactful for the region. Bringing it back to our region, the nor'easter, March of 2023. This was a very strong system with so much moisture available because even though it was March, sea surface temperatures were over 3 degrees warmer in parts, which is more than enough, especially in March, to fuel a system. And that is exactly what happened, dumping 2 inches per hour, snowfall rates across northern New England, resulting in over 40 inches of snowfall in numerous locations across Vermont, New Hampshire, over a foot into parts of central, western Massachusetts. Um, it was I think at one point across the Northeast, I had to parse out the numbers, but there were over 500,000 people without power across the Northeast. You take away Pennsylvania and New York, over 200,000 New Englanders were struggling to get their power back for a few days after this system walloped the region, and it really just came down to the only anomaly. We've had nor'easters forever. The only anomaly was that sea surface temperatures helped intensify this storm pretty darn quickly in a short amount of time to give it the pop that ended up with over 3 feet of snow in some spots. Many homes dealt with flooding incidences, especially with melting snow and the pursuant rain events that happened at the end of March and into April because snow doesn't let the water absorb fast to the ground, so it has nowhere to go but then into properties. Um, that being said, again, I could have done a ton of examples with specific incidences across New England, but the reality is how can we practically adapt to extreme weather? How can we practically be prepared? And it really just comes down to paying attention, right? Now we're in the days of technology where, weather is so accessible. Everybody has it on their iPhone. Everybody has it on their Android. I personally think that the iPhone weather app isn't as accurate. It doesn't tell you really the extreme events that are coming down the pike. I certainly would subscribe to, whatever local news, outlet that you really do enjoy. Um, Pay attention because the amount of information that meteorologists do at a local level is far more ahead of any app that you could download in your phone. Um, However, there are a couple weather apps that I do recommend that do great with alert notifications. I'm a big fan of AccuWeather. AccuWeather does a great job with that. There's a couple of companies, RadarScope does a great job as well. There's a free version of that, but try to get a weather app, even from your local station. Nowadays, they have their own dedicated weather app, which is great. You can get your alerts sent to your phone well in advance so you could be informed and prepared for whenever severe weather does strike. Of course, prepare your home. I believe most people probably already have an emergency kit, but you want to try to plan to have 3 days worth of food and water. Aside from the things that you may need when power goes out, and you can see in the image to my left, your right probably, first aid kit, candles, batteries, matches. There's a laundry list of items that you may not think you need, but would very much need if a severe weather event knocked out power or really kind of made you stuck in a position for an extended amount of time. Other things too, for property owners, definitely feel free to trim branches away from your home and secure loose objects. Um, Most power outages happen because of falling tree branches, and keeping up, especially the fall is a great time before you get into the winter seasons. Um, to 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 trim back those branches to make sure that you have space between your home and your in the trees there because branches knock out power lines very, very quickly, especially when you have branches with full leaves on them. Doesn't do great, especially with snow. Adding weight to the branches, it doesn't take a lot of pressure or a lot of weight to bring those down. Listen to evacuation orders. Um, the National Weather Service, FEMA, local news outlets, digital newspapers like the Globe. We do not want to make anyone's lives any harder than it may be from the day to day or whatever the case may be, especially in a heightened weather emergency. So evacuation orders come at a very last resort when it comes to like how can we keep people safe? How can we keep people informed? How can we disrupt their lives the least? So whenever it does come down to evacuation orders, you have to listen to them. It's necessary. It's a last resort. Um, so many casualties, fatalities, injuries happen in zones that were ordered to evacuate at a tenfold rate versus other areas. Um, Not a great idea to wait on it either. A meteorologist, emergency personnel try to push out any severe alerts, especially evacuation orders, well ahead of time, so you're not running around like a mad person trying to figure things out. But last and not least, check on your loved ones, friends, families, you know, everyone that your neighbors. You just want to make sure that everyone is sort of participating in staying safe, because we are there's only one of each of us, and you want to make sure that you're safe, and you don't want to have more problems than what already could be if an evacuation is ordered due to a severe weather threat. Fortunately, we haven't really had any instances with mandatory evacuation orders as of late, but as we get into more severe weather, extreme weather that is occurring, it's definitely going to be something that is inevitable, unfortunately. And it's always better to say, oh, to be prepared versus saying, oh, I should have done this, I should have done that. And weather, unfortunately, is becoming much more extreme, and it doesn't look like it's going to be slowing down across New England, particularly anytime soon. But that's it for me. I really appreciate everyone attending and would love to answer any other questions that folks may have. My contact information, feel free to always email me directly at ken.mahan@globe.com. I'm happy to answer any questions you all might have. You could follow me on all the things the kids do these days: Instagram at Ken Mahan, the Weatherman, Twitter, X at Weatherman Mahan, or you could just shoot me an email. That's probably the easiest way to get in touch with me, if I'm being honest. But that's it. I'm gonna be done talking about the weather now.
Thank you, Ken, so much. This was a terrific talk, and I invite everyone still with us. If you have a question for Ken, please feel free to drop it in the chat. Oh, and we do have one.
Great.
Give me a moment. Okay, Mary asks, locally, what preventative measures are being put in place? I'm thinking of the storm a few years back, with the storm causing the ocean, levels rising to the point where a dumpster was floating down the street. And I think I remember this. This happened in
Yes.
the seaport.
Yeah,
I recall.
it definitely, it definitely has happened. I remember that vividly. The good news is, broadcast meteorologists that work to, as a public service to inform folks. We're in tune with local government, city officials, even to the higher, state levels, and there are a decent amount of action plans that are table talks to implement that are being implemented to try and curb these severe weather events, extreme disasters from happening, especially across the coast. There was an article like a week and a half ago or so where a property on Cape Cod sold for like, it was an oceanfront property. It sold for like $200,000 when it could have been like millions or whatever, but the property is eroding, and it's just a matter of time where it's going to just fall into the ocean. So it's a big problem. It's very much on the top of many people's lists, and there are action steps that are being implemented. There's a lot of like local agencies that are actively redirecting waterways in certain high risk areas, so water could be redirected away from property, commercial property, residential property, in the event of extreme rainfall, and go into more of a uninhabited area, which is happening at a higher rate up in northern New England because their terrain calls for it, but it's also happening in Massachusetts and Rhode Island and Connecticut as well. There are other things that I am not super in tune with building, seawalls along the North Shore, the South Shore, parts of Cape Cod as well, which are in the works. Some haven't began yet, some have, but it is definitely a major point that, from what I gather, when I interact with folks, that is something that's top of the list.
Yeah. Okay. We have another question for you.
Sure.
Have we lost fish species with warming ocean?
Wow, that's a great question. It's funny. I'm the surface and up. There's a whole nother world with the oceans and below. But from what I know, the answer is yes. Particularly in New England, I know that there's a reduction in the lobster population that could be attributed to changing sea surface temperatures and ocean depth temperatures at the same time. Um, I'm not particularly aware with how other sort of structures below the ocean are changing, but I can imagine so with just how much CO2 within the oceans, how much heat's there, it's changing the behaviors. We see it on the other side where, there's many more shark sightings in New England than we've ever seen before, which is a telltale sign of warmer waters that's present. Um, that is an excellent question, though. I would have to do a little bit more research on the depths. Probably call in a colleague of mine that is that has a master's in biology, in marine biology rather. But feel free to email me that. I would love to follow up with you on that. Send me a note at ken.mahan@globe.
Great. Well, and actually that patron asked two more questions for you. So
Nice.
first is, can we build more marshes along the coast? And
Yes.
is it too cold for mangrove forests?
Wow. I don't think it's too cold yet for a mangrove forest. I think that that's a viable, option. But yes, that is something that is uh, basically being taken from the Carolinas and northern and the coast of Florida, where you start building these marshes, these deep-rooted vegetation that does a great job of basically doing a natural barrier between ocean waters and the land. Um, Extensive projects. From what I know, those are 10, 15, 20-year projects to actually build them to a size that is impactful. But that is an excellent idea, and I have seen that put into action in some places. I know down, well, Long Island side, Long Island, the sound of Long Island on the New York side, that's been happening a lot. Some parts of coastal Maine as well, but that does take some time to really sort of build up and get those roots down into deep depths. But it's a great job of producing a natural barrier, and that's sort of how the Carolinas are set up, as a natural protector against constantly landfalling tropical systems.
Great. Well, Ken, I think we are out of questions at this time, but I want to thank you again for giving us such a terrific presentation. My own personal hope is that we can have you again back with us in the future.
Sure.
And in the meantime, appreciate all of your time, especially the extra time that you've put in. And thank you to all the patrons who are still with us right now. Thank you for joining us. Hope you'll come back and join us again. We don't have any lectures scheduled this October, but we will resume with 3 lectures in November. So we hope to see you there.
Thank you so much for having me, everybody. Thanks for taking your time.
Thank
Now,
you.
now we can go watch the Patriots lose.
Thank you.
Thank you.
Take care.
Thank you very much.
All right. Have a good night, everyone.
You too.
Bye.